Hello and welcome to the AI First Show. This is the show where we talk about all things AI, how to use it, how it can affect your business, your life, making projects, making things happen. My name is Stephen Barr, and today we're honored to be joined by Oli Dinov. Oli, welcome to the show. We're so glad that we can have you, and thank you for joining us.
Yeah, thank you for inviting me. I'm very excited. This is the premiere episode, and I'm honored to be your guest today. Thank
But
you.
thank you. Please just tell us a bit about yourself. And we met through a mutual connection. I was talking on LinkedIn about the AI by the Bay conference. We met Anastasia, and then she referred me to you. So please let's go over your background and how you got started in tech, and how what brings you to this AI oriented discussion today.
Yeah, of course. So I'm Oli, and currently I am the lead producer and co-organizer of AI by the Big Conference, which will take place in Oakland, California in November 17th to 19th. And we have a fantastic program. We have workshops, we have hackathon, and of course, regular talks, panels. So please check it out. And I hope today we can talk a little more about what makes a cool AI engineering event today. So I have a software engineering background. I used to be software engineer, and then I switched to more DevRel, developer relations, community roles, and past few years I've been helping early stage startups with their go to market strategy, how to build a community around open source and not only. And I've just fascinated about the AI and Gen AI in particular, and how things are evolving there, what we see, and the technology. So that's uh, kind of a high level background.
I mean, that's really amazing that skill set of being able to be an engineer, but then also to talk to people, and and kind of combining that engineering plus the business mindedness, advising startups. That's really neat. So here's a question: what was your first moment with AI where it was like, "Wow, I need to dive deeper into
Well,
this"?
even though I've been in the area where AI was used, in the companies where AI was used for me for a very long time, and embarrassing actually to mention, it was more like okay, that's the not what I'm gonna use on everyday basis. So maybe I'm not that interested. And I was more always interested in things like, okay, developer experience. Like how do I make tool that developers are enjoying to use? How to make frameworks that are easy to understand, easy to that are useful and safe and reliable. And AI was always kind of behind what I was like, like I wasn't up to speed, but of course, with the in 2023 to end of 2022, like you see that okay, now that can be used even for my like DevRel community and um or everyday software engineer. That's what we're gonna use from now on. So of course that's when when I was like, that's the moment.
Okay, so around that point, it was ChatGPT 2, and yeah, I guess that makes a lot of sense. It's funny. I rewatch The Terminator probably once a year, and it always felt like, okay, I'm doing this work, and we've got this, you know, this crazy future that could possibly happen, but it felt so far apart. But then the last time I watched it, like, how close? I mean, not in an apocalyptic way, but just wow, we've got some real smarts like at our fingertips now. And all the stuff that it did about reasoning and image recognition and pattern matching and making plans and objectives, like that's all stuff we can do now.
Exactly. Before it was more like, oh, look, they can generate a cat image, or they can now recognize the type of clothes on this photo that like a woman wearing this blue or yellow or like gold dress. Okay, kind of news like that. Yeah, I would look at it, or sometimes I would feel like, okay, I need to look at the deep learning and understand more. Like, but that's engineering curiosity more than anything I could do. Practice at my work. But now I cannot imagine a day passing by without me uh, trying to use AI tools or trying to understand like the principles of building good AI systems, enterprise AI systems, etc.
So let's dive into some of the engineering related things. That's your engineering background. I have to start with this one. What's your favorite programming language and why? And I know it's a leading question, but yeah, tell us about your favorite programming language.
Yeah, it's hard to talk about like favorite programming languages, knowing that some people are very sensitive to the topic and they're like, oh, how could you say this or that? Or like without this and that. Well, right now, I don't feel like I have a favorite programming language, to be honest. But there were times when I definitely felt much, much stronger about that. And I even had a podcast called Scala Love. So there is no doubt there of which language I was my favorite. It still is in some ways, but it's more like now it's nostalgia than versus like, something that comes to practice. Um, so Scala, yeah, definitely has a special place. But otherwise, I think my vision on programming languages in general and engineering has changed. Have changed over years. So and part of it actually AI too, because now with AI coding tools and vibe coding in general, it doesn't really matter which language that much. I mean, it always helps if you are building very complex and high load systems. There, it helps a lot if you know nuances. Otherwise, the I think it just lost the idea of knowing the language inside out lost its beauty right now, because if you use vibe coding, important part is, do you understand engineering principles? Can you make it reliable? And some languages help, of course, with making it reliable out of the box, but otherwise you just need to think more about like what's APIs, like what, I don't know, like, you know.
So that's interesting that the language itself has almost become like an intermediate step, and you're not as like, I know, and we talked about this in the show warm up. I had a very soft spot for Haskell. I've had some Haskell code in production, and when you see a new library or a database coming out, the first thing you Google is, okay, can I talk to Neo4j and Haskell? And okay, this is great, I can. But then you look at it as from a more experienced perspective. Okay, maybe there's something on GitHub, but it's maintained by two people and has 8 users, whereas the Python version has 10,000 users, and they've already hit all the edge cases.
Yeah, exactly. That's what happened when I looked at Python more seriously. That was because I wanted to play with hack and face and models there, and I needed Python for that because the entire ecosystem was in Python, and there was no reason to stick to Scala. And now it's even less reason to stick to one language because of the AI generated code. Well, you need to understand that anyway, but it's I'm on the edge of seeing like, of being perceived like I'm all for vibe coding. I'm not. I need to make a clear disclaimer here that I do think we should use that in a very limited way, and in that after you generated it, you need to understand what it wrote. You need to make sure that all tests are intact, and you know uh, don't generate, close your eyes and hope it works.
Well, and I think we'll definitely get into that as part of the discussion, right? the kind of reliability that we think of from, I suppose, a strongly typed language setting where it's okay. There's pure principles all the way down, but then there's also the reliability in the more, I don't know, organized chaos kind of way where you have systems in place at certain junctions that catch things, right? Like an API barriers. And I wanted to ask you about that as we get to that section, right? Of how do we deal with resilience and reliability in a more in this more chaotic and fluid environment, right? Where we're not statically compiling everything into one perfect executable. But before we do that, let's talk about what you're doing now. The By the Bay AI by the Bay conference is coming up. How did that get started? And what topics are you covering? I'm really looking forward to it. And gosh, it's only a couple weeks away.
Yeah, so well, it's 3 more than a week. So oh my god, that's time is flying. So AI basically started quite a few years ago. It's over a decade old, decade old. Well, not AI basically. I need to say, by the Bay community started like 12 years ago now, and we had 11 different conferences, and it's together in once a year. Otherwise we have meetups throughout the year every month. For example, AI agents SF is one of our events, and we had Scala by the Bay, we had Database by the Bay, and AI by the Bay first came in 2017. And I just checked today, AI.vision is the URL to that first edition, and it's still up. And some of the guests from 2017, they're coming again. Some of the speakers, I'm sorry. Peter Norwick, for example, he's the just canonical book. I think when we were preparing for the show, you even showed me the book on your
I'll go
shelf.
get it.
Yeah, yeah, you're gonna get it. Yeah, so we're very for me like yeah,
This
it's
guy.
university. Exactly, exactly. That's the classic canonical book, like how you learn about the AI programming. So, and I'm originally from Russia, and I went to the university there in Novosibirsk, and that was quite some time ago. And I remember, I, I don't think I would have ever imagined that I would have Peter Norwick at my conference somewhere in San Francisco. That sounds like a, I don't know, building a rocket ship. And uh, yeah, so that I'm very excited. Some of the people like Tom Brown, he's now co-founder of Anthropic, was there in 2017 at our conference. So it's interesting because in 2017, that's you need to understand that's quite a different way to look at AI. So I wasn't part.
It was all big data, and we were all focused on is this algorithm or that algorithm or tree this or regression that, right? It was not the general way that we think now.
Yeah, well, agentic AI wasn't a thing at all. So now it's much more wider, applicable, and yeah, for software engineering. So the way we think about this now at the current edition is, we want to talk about reliable enterprise AI. So we want to cover things that we'll learn throughout the year about how to build distributed AI systems. And we do believe that thoughtful software engineering, which is our flagship track, is now coming to AI systems. So it's now beyond the point where you can just play with from your Jupyter notebook with a model and that would be it. Like, chatbot. Now people actually have ambient agents that are running all the time, do their own things, and you need to think about it as a part of the system. And a lot of our friends from previous years, they're now helping enterprises build um, AI systems. So we're very excited to cover these topics from all the angles that are possible. And type safety, for example. We just talked about like strongly typed languages, and I'm excited about two projects. BAML is one of them. That's the way to write uh, typed prompts. Then DSP is another angle on a similar problem. So that's context engineering. Then we have actually all aspects of it: agents, memory, MCP, how to scale your infrastructure for building AI, etc. So that's the point of the conference. Yeah.
Okay, so very very focused on enterprise and on getting this to work in corporate settings where you have to deal with. It's funny, right? Businesses want predictability, and I guess the scary thing
Exactly.
about AI is that it could do or say anything.
Yes,
Um,
exactly.
yeah.
Yes, that's the focus. We still do have Peter Norvig, who's coming from Stanford, to talk about the future of AI, which was very visionary. It's not necessarily like enterprise focused. It's a different story, but we want to talk about this broad and wide and far.
I'm going to pull up the website because I really like it. So you mind if I'll share my screen really quick? Okay, so
Yeah, of
there's
course.
AI by the Bay, Reliable Enterprise AI Conference. We've got tickets here on the registration page. Still time to register.
Yes, please be our guest.
Awesome. I'll make sure that the link is in the show description. We're going to get this
Yeah,
edited and out there as soon as possible. You've got a great lineup of speakers. Let's see. Okay, we've got Samuel Colvin, founder of Pydantic, Ryan Boyd, Tyler Jewell, Matt White. There we go, Peter Norvig. I love the theme you've done with the colored shirts. That's clever. It really
yeah,
jumps out.
yeah, yeah,
Uh, yeah, really great lineup of people. Even my
yeah.
friend Lena, CEO at Droid AI.
Yeah, yeah.
Yeah,
She's
this
coming. Yeah. Well, right. She moved to Akamai now, so we should update her actually.
this is great. It's a really good lineup of people.
I feel like this is an old page. Can you?
You're right. It says speakers dash old. Why does it?
Yeah. So
Here we go.
yeah, yeah. That's the new one.
I think I was
So
browsing it maybe earlier and I got a cache
yeah,
version.
yeah, yeah,
Okay.
yeah, 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 yeah. Yeah, because we updated her. Lena's.
Here we go.
Yeah,
Senior. Cool.
yeah. I'm very happy to have her. Yeah, and Gemma just joined us with the new keynote. We haven't announced it yet, but you can see her on the upside. Yeah,
Next data.
yeah. She's creator of Data Mesh, and she's gonna talk about her vision of data and AI, and it's very interesting, in depth keynote. So I'm looking forward to it.
Neat.
Um,
How long is the conference? Is it a couple of days or
uh,
3 days?
yeah, so first day is the workshop day, and we're gonna have a Pydantic workshop, plus we're gonna have AWS, MCP, Spring AI, Amazon Bedrock um, workshop, also full day. And then on the other 2 days, it's gonna be talks and hackathon and panels and all of it. We're gonna be posting the program like really soon, because right now I have a list of the thoughts, but I haven't posted the program, so it's about the time to do.
Got it. There's here. I'll put the talk slide here. Here we go. I like this durable agents, long running AI workflows in a flaky world.
Yeah, and he's gonna show he said he's gonna be live coding, so I'm very excited about that.
Wow, that is, as anyone has ever
Oh,
presented, that
spec
is.
driven development is very interesting talk. Yeah, here's by Bruno. No, a little.
Here we go. Yeah,
Yeah,
Bruno
yeah, by
Boisens.
Bruno. Yeah, yeah. He's gonna talk about the framework they have. Basically, We always talk about how the like BDD, TDD, and coffee-driven development, and this one is spec-driven development. With AI now, it's possible to work with the documentation and make sure that what documentation says is
Well, and
what actually is happening
this
in the
is
code.
the idea behind Amazon Kiro, right? Where you have
Yeah,
a spec and you have a much longer running agent, which is going to make its own plan to implement the spec. So you have a somewhat formal document that's usually in Markdown and says, okay, this is what I want to have happen, and let the agentic system behind that figure out how to implement the spec and how to test against how to make sure the spec works by usually coming up with a testing framework. So that's pretty exciting. Let's see. I'll keep
yeah,
scrolling.
exactly, exactly. I like it. Then, uh, Laura, I really love her talk about the graphs and how that works, because that's like everyone is excited about the vectors, vector DB, and we haven't heard enough about graph knowledge. I don't think so, and that'll be an awesome addition. Yeah, Lena, of course. Let's see what's up. And Ryan is gonna post his abstract soon. I'm waiting for that. He's gonna talk about the also the agentic and real-time analytics for AI. And yeah, here too, Steve Chin is talking about the graph rack and context engineering for that.
GraphRag, that's a really big one, and especially with
Yeah.
Neo4j. A long time ago, I'd worked with Neo4j in Haskell, mind you,
Oh,
well,
yeah, yeah, yeah.
to represent patient care pathways in a medical setting as graphs in Neo4j. So that's how I get started in that. But it's perfect for graph representation, graph knowledge. This is cool. Okay, let's see. Angie Jones at Block.
Yeah, Block, they implemented their like AI system MCP, etc. on a very big scale. So she's gonna be talking about that, and I think a lot of people excited about Block and what they do for like AI.
Wow,
Yeah,
you've really
Letta
got
is very cool. Yeah, yeah, we have Eric Mayer too. He's joining us, one of the classic voices in AI too. I would say canonical, like speaker. Oh, and I absolutely love Holden Carell's Fighting Health Insurance project. So she helps people to write claims to the health insurance and submit appeals. And that's all done with like fine tuning LLMs. And she's talking about that. She's an expert in Spark and many other things, open source. So that's very exciting. Yeah.
that is that's really cool. I had a friend. It's his story, so I won't say who it is. He was dealing with a health insurance claim that was very personal to him, and he had to use Chat GPT to go through all of the contracts and the terms and the conditions to kind of prove that the healthcare was um, prove to the insurance company that their claim was reasonable. And
Exactly. So that's the project part health insurance, but instead of like general the LLM, you could use the one that is trained on this health insurance data.
you get agents
Yeah.
with Spring, MCP,
Yeah,
Java, and
this
Bedrock.
is a workshop. Yeah, this is the workshop, and then we have Julien Dedem is joining us. He's a creator of Parquet, and obviously he's talking about open data lake formats and how to use them. Oh, Lisa Cow from Databricks. She's incredible mind in the data ops. So her talk is about catalogs, and I assume Delta Lake, and yeah, that's an exciting talk for sure. All of them are exciting,
This is
actually.
great. Well, I mean, yeah,
Yeah,
keep scrolling. It'll take a long time to go through all of these, so just keep
yeah,
scrolling.
and
Check this
it's
out.
not all of them actually.
Yeah, that's okay. So make
Yeah,
sure, talking to the audience, make sure that you if you can make this work logistically, check out AI by the Bay. This
Yeah,
is
yeah, yeah.
happening in November. What's the date? November 20
17th, 18th,
17th, 18th,
19th.
17th,
Yeah,
18th, 19th in Oakland at the Scottish Rite
yeah,
Center,
yeah,
Oakland, California.
yeah. And I'll be sharing the code for the audience for the discount.
Oh, awesome. Thank you very
Yeah.
much. So check out that. It's be in the description. Thank you, Oli, for the code for
Of
AI by the
course.
Bay. That's really exciting. And for all of our viewers, that is a really cool opportunity. If you can get there, I'm going to try and make it work on my end. My life is logistically complex at the moment, but it looks pretty awesome. I really want to try and make it. So this is cool. Um, to talk about reliability in engineering, because
Yeah.
so given your engineering background, like how did you kind of get into this space of reliability engineering, and what made you interested in it?
It's just it came naturally after I kind of digged into Scala functional programming and category theory. I was and I also worked at Expedia as a software engineer on the payment system project, and Expedia is it's a group of companies. So hotels.com, for example, is Expedia, etc. And that platform worked for all of the brands, and uh, of course you want it up and running. And I was proud to make an a a bug, which led to not working the entire platform. The entire payments didn't work for all the website for half an hour. So,
Oh, so no one could
which
no one could book their hotels, their flights.
yeah, which is like millions of dollars, and probably that's you probably want to think about reliability when you do things like that, and you think like
Well, and I think that's what really. I mean, all engineers have to go to this point of like how messy the real world is, right? When you see them interacting, when you see your users interacting with this product, and you think, okay, I have this vision in my head of how they're going to use it, and then you see them interacting with it, it's totally different, and it makes you like how defensive you need to be as a programmer when your stuff is exposed to real world and possibly even hostile actors.
well,
Um,
it's not even only the real the like external world. It's also the internal. Like sometimes you're like, okay, I'm gonna just quickly push that directly to the main branch, and everything will be perfect, wouldn't it? I mean, yeah, and then you need to think about like observability. You need to think about testing. You need to think about how you release the stuff, CI/CD tools, etc. And you want to be in charge of every single step of it. And it's that happens before you even hit the production and someone interacts with you. Like everything can fail before that. So it's a lot of steps.
and that's a really good point where imagine a lot of people are talking about AI being able to check out all of your issues and then go and solve all of your issue backlog. But then when you actually dive into the details, sometimes you say like, oh, okay, this AI solved this issue by like commenting everything out. Uh,
Exactly. That actually happened. Like I've seen the problem like that in production at one of the companies. I just laughed out loud. And that how happened like at night or something that nobody could see, and agent went wrong and like pushed everything.
wow. So it said fix this bug by
Yeah.
disabling this feature. And that's where one of those things like,
And removing the test as well.
oh wow.
We can't fix it, therefore. No, like the real commit message was something like, "We can't fix this feature, therefore I'm removing the test." And
So AI learned how to move the goalposts.
yeah,
Wow. Okay. And so that's one of those things where it's like that's kind of the danger of maybe over personifying AI. Is like we think, okay, in our head, fix the bug means get it to work. But
Yeah.
if we state the objective wrong, it could be like if you say eliminate the error, well, yeah, that you can just comment it out.
That. Yeah.
Well, what other I guess what other stories do you have of perhaps vibe coded fixes gone wrong, or vibe coding in general that maybe hasn't produced the result that you wanted it to?
Well, it's all over the internet actually, and I was surprised because part of why I want to do this conference is and talk about reliable enterprise AI is that I want to reduce the number of errors that are coming from bad coding. Like we have a talk about that by Bart Sadekursky. He's talk like we've been. Uh, is vibe coding wrong? Maybe we asked a different, like a wrong question, something like that. That Tackle says, and he's talking exactly about like uh, how to vibe, how to um, leverage from vibe coding without, shooting oneself in the own legs. So how to do that, and yeah, techniques are all same old things: testing, verification, CI/CD.
In the Haskell community, there was always often this phrase of like, okay, if it compiles, it'll work. And of course, you can always have situations where that doesn't work, and it usually has to do with like input sanitizing and things like that. But what do you think of, I guess, the trade off of using a particular language or framework versus agentic test versus like testing after the fact? How do you kind of weigh those two?
Well, look, Haskell is a very rich and has very rich type system, right? It's not that many programming languages, and especially the popular languages that have this rich um, type system. And by that, I don't mean just like type safety that um, a lot of people might think, okay, something compiles. I read code in Java and it compiles, but it might not still work, right? And it's hard to um, explain in a couple words, like why is that true for Haskell, right?
Mm-hmm.
So there are like dependent types or I don't know, all these monads factors. The idea is that you uh, the liberty what's it,
Well,
phrasing the constraints that the language puts on the what you can say or what you cannot say in that language are liberating you from making bugs. That's what I would say.
that's a good. And so now, I think very little of our development isn't limited by the language, but maybe is limited by tests or by our ability to tell an agent, right? Maybe we have a CI agent. We're just saying, don't merge this into main until it does this and doesn't do that, right? It's so we're not necessarily using the expressiveness of the programming language, but more the expressiveness of our natural language, I suppose.
Yeah. Or, well, at the end, have human in the loop and just don't let. Well, that's a good question. I don't think I have a good understanding for well, for each particular case when you see it, you know it.
Mm-hmm.
What's the balance? But like overall, I hope I'm sure like many of the speakers that we have would have that answer. I my bet would be like if you ask Eric Mayer, he would explain you perfectly whereas this balance is. I don't necessarily have that strong opinion on that.
Well, I think it's something that we're going to keep. It's like a moving boundary, right? And as the AI gets more powerful, and as we get more experience with it, I think we have to keep revisiting what that looks like.
Yeah.
And so I guess that was one of my other questions to you: is like, how do we blend? AI gives us all these advantages, but then sometimes we kind of it's like we forgot all the stuff we learned over the last 50 years about regular engineering. So how do we get the best of both worlds?
Oh, we cannot forget. We cannot forget what we learned about the engineering, because there is no such thing as a vibe engineer. There is vibe coding. Like it can generate code for you, but other things you have to think about it yourself. Like, oh, even APIs can be generated by AI. Yeah, I get it, but you as an engineer is responsible to for things like modular design, for example. Um, like AI is doing even not a K-ish job, but it does something. But it's for scalability. You have to think about it yourself. Like, what is your cluster? What are components of that cluster? You, as a person responsible to understand how your system is going to be used, where you need to, where are your bottlenecks, and etc. AI can help you, but it's only your responsibility to like make it modular and scalable. And then observability, same problem. AI can put some of the things for you up, but that's it's not gonna solve it.
I like that a lot. So still having to have the principles of how do you design a program, how do you take a human challenge and break it down into an algorithm, and how do you know which information is needed where and when, and those are all things that AI can't solve for us yet.
Well, at least not now. Yeah.
Yeah, exactly. Well, I guess so. Using that not now, what technology are you most excited about? Like, what would you want AI to do that it doesn't do yet, or just in general? Like, what are you excited about in the AI future?
Well, it's moving so fast. We used to joke a lot about like front end, uh, like frameworks popping up 5 a day, and now you're like too old if you have 2 years of experience in something, or because like you need to be like brand new, fresh from like 2 days, be up to everything. So
Oh
I
yeah,
f- I
there's
feel
always.
like that in the I feel like that in the AI space right now, because like people will be, have you heard about Cogni? And we have a speaker from Cogni, it's AI memory, and it's fantastic. And I'll be like, okay, I need to Google right now, and they're like, how come haven't you heard about it? And I'm like, oh, well, my bad.
Yeah, it's been out for like 6 months, right? Like,
Exactly. Yeah, so and a lot of excited projects like that. Yeah, definitely look at Cognitive, for example. Yeah, I'm excited about agents in general. I would say I'm excited to see agents, because these are distributed systems, um, but in a new way, in a both more accessible and both that require more engineering. Because I used to love Scala a lot and functional programming a lot, because that would be my like engineering teaser.
mhm.
And now agents are what excites me, and but that's like more like a current thing. I understand about the future. Well, I hope we can make even more sophisticated things with it, and automate more. But at the same time, I want this system to like I want to find more analytical ways to solve problems, because right now we all depend on AI, and let's be clear, LLMs are just a way to predict which word is coming up next. You know, like what's the most probable word that
Mhm.
person would put there, and this is not a reliable thing, right?
So, okay, I've always wondered this because sometimes I think, like, could I prove that I wasn't an LLM, and if so, how? Like, is my whole cognitive system just an abstraction around making me a really good token predictor? And I'm not sure of that, right? Like, we want to think that there's some
Yeah.
fundamental knowledge representation that we have that differentiates us from that. But I'm not. Every single time I think about it, I kind of get stuck there. Is like maybe that's that whole next token thing is just a really good objective function, and having a brain is just helping me get there. But I don't know.
Yeah, yeah. When I was at university, I the topic of my master's thesis was around the um natural language representation in ontology or something like that.
Hmm.
And there was um, now I see that was the wrong way. I think I should have spent time more on learning all this techniques, like spend more time in the like linear regression. I don't know, reinforcement learning, something like that. But still, I still feel that influence, even till now. That choice that I made back then to work on more like analytical ways still influenced me, and I feel like yeah, maybe
So was that like the semantic web and like structured knowledge graphs and all of that stuff?
like, close to it. Yeah, 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 yeah. Exactly. Like you build based on the sentence, you look at the semantics and try to build it like a structure around that, and then using that structure, I even came up with the formula, like how to say which words are similar or not, and yeah, fun times.
Well, here's a question. What do you think is the most important skill then for being a builder in 2025, 2026 soon enough? What's the most important skill? If it's not programming, if it's not, back in the weeds like we used to be, but what's the most important skill then to make things happen in the tech world?
Well, engineering holistically, like it doesn't have to be. You need to understand what database is, what are the ways that different systems talk to each other, like networking, what are like some safety fundamentals, like what different types of attacks, etc., and go into like scaling, understanding different patterns for um scalability in general. Yeah, all things more high level, they are bigger than the programming language.
I like that a lot, and I think that it used to be very comfortable to kind of get zoomed into the details, and it felt really powerful to like know all the esoteric bits and pieces. But now it's like we're kind of forced to think about the big picture more often because the
Yeah,
LLM is doing all the hard the
exactly.
minutia
Yeah,
for you.
yeah, yeah. Exactly. So I think the work of the engineer, like before, you would have junior engineers who are working on the like in this particular class function. I don't know, like very very tiny bit of functionality. Now, since LLM can help generate you some code, you don't need a junior engineer. Not that I compare them to like one by one, but still, you understand your
Yeah.
responsibility as the software engineer now can be bigger because of how things are automated. So I feel like it just like every level of engineering now requires more understanding of the how different pieces work. Like before, you cared only about the single bit, and um, like senior engineers would be thinking about like more if it's microservices, they were thinking about their service and services around, and then someone on top thinking about more of that in interoperability. And now I feel like there is a shift in what every level should understand more.
So now the junior level, you can think at systems in any level, and you're not getting because all of us have been there at the junior engineer where you're like implement this class and you gotta get the getters and the setters and all that little stuff that is the once the problem has been solved, then there's still all this work to do to actually implement the solution. But now that part's kind of a lot faster, and so now we all get to think in the in the systems and things like that, and
Exactly, exactly,
bring back to the actual objective at hand, I guess.
exactly, exactly. Yeah, that's I will. It just allows you to do more like interesting and uh, more difficult, more challenging uh, level.
Awesome. Well, I think it's been a really great conversation. I'm really looking forward to AI by the Bay 2025. It's coming up again. That is November 17th through 19th, Scottish Rite Center, Oakland, California. We've got a great lineup of speakers. So congratulations in advance for putting that all together. It's been neat to be in the same room with all these people and sharing ideas and learning the state of the art, especially since it's changing so fast. So yeah,
Exactly. Yeah.
congrats for putting this all together,
Oh,
and
thank you so much.
we're going to yeah, we'll put that code in the description. So thank you for that, audience members. Make sure to have a look at that, and thank you, Oli. Really appreciate your time.
Yeah, thank you so much for having me. That was a blast.
Thanks.